Okay, if you have been following along with solving quadratics and working with these complex numbers, remember the imaginary number uh, I, numbers like a plus bi, um, then this will be should be a piece of cake because we've already used the square root method, and that's what we're going to review today to get us ready for the next topic. Remember, our entire goal that we've been working on is been solving quadratic equations. So we're trying to solve equations that are in this standard form. They come in different forms, of course, but the highest exponent will always be an x squared, and that's what makes it a quadratic equation. Now, the square root method, we practiced it previously, was when the b value here was 0. So if b equaled 0, then we could use this square root method. So let's look at an example of that. Let's say we had x squared equals 4. This is certainly quadratic. The highest exponent is 2. Note how this x squared is isolated all by itself on the left-hand side, and all we had to do was square root both sides. And remember, when we square root, we always get plus or minus, and in this case, the square root of 4 is 2. What that tells us is that 2 squared would make this equation true. 2 times 2 is 4. And negative 2, if I squared that, negative 2 times negative 2 gives me 4 also. So this equation has two solutions, which we always expect when we're solving quadratic equations. The exponent will tell us how many solutions we get. Okay, now today what we're doing is exactly the same thing as this process, the square root method, except previously when we had a problem such as this example, when we first did this and I go, hey, square root both sides, we could not square root a negative number. We didn't have the mathematical knowledge to do that because you can't take the square root of a negative because there's no two numbers that multiply together that give you a negative. Remember, it couldn't be 2 times 2 because 2 times 2 is 4. It's not negative 2 times negative 2 because that would be positive 4. But now that we have the complex numbers and the imaginary number I, we can do problems like this. So instead of stating there are no real solutions, we can actually give an answer. Just like before, it's plus or minus, and now we have to square root negative 4. And we talked about it the other day. We practiced it. When you square root a negative, you automatically get an I. And then we square root the 4 just like normal, so that's 2. And we'd get plus or minus 2i. So we do have two solutions, positive 2i and negative 2i. So we no longer have to put no real solutions. Now, when we solve quadratics, you also have to pay attention to the directions. If directions say solve over the real numbers, that means you can have no i's in your solutions. So if this said solve over the real numbers, we'd say, hey, there are no real solutions. And then if your directions say solve over the complex numbers, then you are allowed to use I. Okay, so it kind of depends on the situation and what type of problem you're trying to solve and what the directions are. Now, if they don't say either one, I would always assume solve over the complex numbers and you'd be safe. Okay, and say, yeah, I know it's plus or minus 2i. Okay, because we're assuming now that's our biggest set of numbers. So they'll be kind of explicit. If they just want it over the real numbers, it'll say it. Otherwise, you can use imaginary numbers. So that's all we have to do is take square roots of both sides, or at least get it set up first, and then take a simple one. I'm going to go back to this problem so you can see how a check would look. So I'm looking for the solutions for x squared equals -4, the original problem up here in the bright red. One of the answers, I believe, is this positive 2i. The other answer, I believe, is a negative 2i. Here's how a check would look. Substitute 2i in for the x, and the question is, does that equal -4? Well, 2i times 2i is 4i squared. Remember from yesterday, I squared is equal to a -1, so it's 4 times -1, which is -4. And so it does check on both sides. And by setup first, I mean this problem right here. This is an ax squared, so it's an x squared. There is no x term in the middle, and then there's our constant. So there's no b term in the middle. And so we just want to isolate the x squared. Subtract 8, x squared. 8 plus -8, or 8 minus 8 is 0, so that disappears. And now the x squared is by itself. We can square root both sides. X equals plus or minus. We poke out the I, and now we just have to simplify that 8, or that root 8. Okay, so let's take a look at how we do that. Square root of 8, we're going to think of that as a 4 times 2. We want to think of it as 4 times 2 because I can square root of 4. Square root of 4 is just 2. So that 2 pops out, gets multiplied by the I, and then that other 2, it stays in there. So that's that 2 right there. He's not a perfect square, so we just leave him. So again, we get two answers. We get 2i root 2. We get the other answer, -2i root 2. Very abstract and complicated answers that will make this equation true. Okay, these are all checkable, but it's a little bit cumbersome. But the same thing would work with -2i root 2 and 2i root 2 in this quadratic right here. Let's take a look at another one. Remember, in solving for x squared, we want to get that x squared isolated, or the squared thing isolated. So in this case, I would take that 12 to the other side, slowly trying to get that x squared by itself. X squared's almost by itself at this point, but it's got that 4 in front of it. So we're going to divide by 4. X squared equals, so it's -3. X squared is isolated, square root. X equals plus or minus. I'm square rooting the negative, so I poke out the I, and I'm left with a 3, and 3 is prime, so I can't factor it to make a square root out of it, or into a perfect square. I'm done. Two answers, I root 3 and -I root 3. You don't have to write two separate answers. This implies to all mathematicians, positive I root 3 and -I root 3 are both solutions to this original inequality. Now, those are kind of warm-up problems. The ones we really want to look at, and the problems that are getting us ready for what we're talking about on Friday, look like this guy right here. These problems are kind of strange looking, because if we were to expand this x plus 3, and by expanded I mean take it times itself, like this. Remember, when we square a binomial, we have to write it twice. We would get this really big trinomial. We don't want to do that. In fact, this is set up perfect for the square root method. If I square root the left and square root the right, note what I get. X plus 3 equals plus or minus. I'm square rooting the negative, so I get an I root 8. And look at what happened to the left-hand side here. This x is practically by itself. It's just x plus 3. In fact, if I want the x alone, I just move the 3 to the other side with a little subtraction. move that 3 over. X equals 3 and negative 3 add up to 0. I got a negative 3 on the right-hand side, and that plus or minus I root 8. Now that's a pretty darn good answer right there, but 8 does break down. 8 can be factored as a 4 times 2, and I can square root of 4. So we'll square root that 4, put the 2 outside, and leave that other 2 inside. And that is a perfect answer, a very complex answer. In fact, it is a true complex number in the fact that it has a real part, the negative 3, then it's plus this imaginary part, 2i root 2, and it's negative 3, then minus the imaginary part, 2i minus 2i root 2. Okay, but again, the process is the same. We had this quantity squared. We square root both sides, simplify, and just throw the other term, that other constant, to the right. Let's take a look at another one of these. Note this quantity squared, and the x is inside that. It's important. Okay, I can just subtract this 2 right here. Now I can square root both sides. Now that squared is gone. Plus or minus, I'm square rooting a negative, so it's I root 2. I just have to add the 5 to both sides, and I know exactly what x is. It is a positive 5 plus or minus I root 2. Two answers, 5 plus I root 2 and 5 minus I root 2. Okay, that's what all the problems entail for today. Just using the square root method, which we've used before, and taking square roots of negative numbers, and instead of saying no real answers, now we're working over the complex numbers, which means we can put I, that imaginary number, into our solutions, and those answers will still make this equation true.